Okay, we're going to do this example. How much work is done lifting a 1.2 kilogram book off the floor to put it on a desk that is 0.7 meters high? So what I've done is I've drawn this diagram here, which is not super involved, but this little picture where I have the floor and I have the book sitting on the floor. Okay. What we're going to do is we're going to use, finally, what we're trying to find is what the work is, and work is force times distance. So now let me back up and say, well, what's the force? Okay, force is mass times acceleration. In this case, acceleration is the constant acceleration due to gravity. So the acceleration is g equals 9.8 meters per second squared. So when I use this formula, I have the mass, which is given as 1.2 kilograms, and I multiply that by 9.8 meters per second squared. Now, a kilogram times a meter a second squared is going to give a Newton. So I take 1.2, multiply it by 9.8, and that's going to be N, standing for Newton. And I can get the exact value on the calculator, or I think I could figure it out by doing long multiplication on the side of the paper also, but I'll just put that in the calculator. Okay, now I move on to the next formula, which is really what I'm trying to find is what the work is. Work is force times distance. I take the answer from above. The work is 1.76 newtons. And then I multiply it by the distance. This is D right there. It's 0.7 meters. Speak up if I'm, putting the wrong number in, okay? But I think it just says right there, 1.2 kilogram book is being moved a distance of 0.7 meters. Now, when I multiply this, I'll get, 11.76 times 0.7. A meter Newton is a joule. Or maybe I think they say, sorry, I think they do Newton meter is a joule. So I do 11.76 times 0.7, and this is an exact value, not an approximation, 8.232 joules. All right, so, we had two formulas that we plugged into. The force equals mass times acceleration, work equals force times distance. This is a situation where the force is constant. So the gravity is, technically it changes the farther you get away from Earth. But anyway, you lift the book up 0.7 meters from sea level. It's for all purposes for us, it's constant. We'll assume it's constant. Now, let's do this next one where we have 20 pounds weight. Now, the thing to know about this is now in the US customary system, the 20-pound weight is actually a unit of a force. So F is actually 20 pounds. That's not a unit of mass. And then the distance is 6 feet. And so we just put it into our formula for work when, again, the force exerted on the object is constant, and work is equal to force times distance. And so work is equal to 20 pounds times 6 feet. And I can do that one in my head. 120 feet-pounds is what the work is. Are there any questions about that? Do you have any questions about how to do that problem? This is a problem where this fits into the heading of constant, or the force is constant. Force is constant. Okay,